Comment 1728 is about what happens when things disappear. Now, things disappear all the time in just your ordinary mathematical work. So, for example, if 3x equals 6 and you divide both sides by 3, then the 3 disappears. Or if x plus 2 equals 8 and you subtract 2 from both sides, then the 2 disappears and you get x equals 6. I guess what I'm saying is that the reason why something disappears is that 3 divided by 3 is 1, and 1 doesn't make any difference when you multiply by it, so you can just pretend it's not there. 2 minus 2 is 0. 0 doesn't make any difference when you add it, so you can just pretend it's not there. Another famous example is x divided by 2 equals 10. If you times both sides by 2, then the 10 becomes a 20, and over here the fraction line and the denominator just disappear. And the reason why they disappear is that if you have something you divide it by 2 and then you times it by 2, you just get back to where you started. So that's all fine, but what comment 1728 is saying is that sometimes you actually have to put the 1 in. So, for example, if you had y equals yx plus y, and you divided everything by y, that y will disappear because it becomes a 1 that's multiplying by an x. Therefore, you don't have to write it. However, that will become a 1 because y divided by y is 1. Y divided by y over here is 1 as well. So that y disappears, but those don't disappear. They just get converted into 1s. Another example, let's say you have y equals 2x plus 4 and y equals 7x plus 3. And you do, or 13 let's say, and you do 3 subtractions. So you go that minus that, 9, that minus that, 5x, that minus that. Now, that disappears, but you can't just leave it blank because then you'll have an equal sign that's not connecting anything. So you actually need to write the 0 there. So while zeros and 1s often disappear, sometimes you have to leave them in, and that's what comment 1728 is saying. Just one last other scenario that I thought of. 2x plus y equals 8. 3x plus y equals 11. If you do this minus this, you'll get x. This minus this, you'll get 0. This minus this, you'll get 3. You can leave that out because 0, when you add it to something, doesn't make any difference. But just because you can leave the 0 out there, it doesn't mean you can make this blank, and it certainly doesn't mean that you can leave out these 1s. Just another thing I forgot to say is that same thing with when you cancel fractions. So if you have, I don't know, 2x over, let's say you have 12x over 4x, and you cancel the x's, and then you cancel the 4's by dividing top and bottom by 4. Then you get 3 over 1, and of course you can leave out the 1. That's why the answer becomes 3. That's not the case if it's the other way around. If it's 5 over 20, you divide top and bottom by 5. Then by all means put a 4 at the bottom, but the top will not disappear like the bottom disappeared here. It will become a 1 that actually has to stay there. The reason is that 3 over 1 is 3. The 1 can be left out, but 1 over 4 is definitely not 4. The 1 can't be left out.